Hello, and thanks for checking out Chemistry Connections on the Hopewell Valley Student Podcasting Network, a proud partner of hvspn.com, where students come together to publish content to share with the world. The opinions represented within this episode are those of the content creators only. Please enjoy the show.
Welcome to Chemistry Connections. Our names are Julianna Silva
and Chloe Mcgregor,
and we are your hosts for episode number 3 called The Chemistry Behind Rainbows.
Today, we will be discussing exactly how rainbows occur after a storm, how the wavelengths of each color work together, and how acids and bases cause acid rain to change the appearance of a rainbow.
Have you ever wondered how exactly rainbows occur after storms? Well, it's an instinct to run outside after a storm to go look at them. But why exactly do these beautiful rainbows occur?
Just last week when I was driving during the storm, I saw a rainbow right outside my window, which gave me the perfect idea for our podcast episode. Throughout the first segment, we will be going over the basic components of a rainbow and exactly how the water and sunlight work together to expose the 7 individual colors of a rainbow. To the human eye, the light that comes from the sun appears to be white. However, this white light is actually composed of the 7 wavelengths of color. A wavelength is the distance between successive crests of a wave, especially points in a sound wave or electromagnetic wave.
Each color is unique to its wavelength. The color red has the slowest and longest wavelengths, while violet, on the opposite side of the rainbow, has the shortest and fastest wavelengths. When all these wavelengths are together, they produce the normal, visible white light.
The electromagnetic spectrum consists of an array of wavelengths that produce a variation of radiations such as ultraviolet, infrared, radio, gamma rays, and X-rays.
On this same spectrum is a visible light that consists of 7 wavelengths of color combined. When these 7 wavelengths of color are combined, they produce a white visible light that we see from sunlight.
However, after a rainstorm, when H2O molecules are present in the air, the white light is able to hit a new medium. Compared to the air, the white light uses the water molecules to refract, causing the 7 separate colors to become visible to the human eye. The interaction between the white light and the water droplets cause the wavelengths to separate and therefore produce a rainbow across the sky after a storm.
One of the main reasons why wavelengths are separated when they hit water is because water is much denser than air. The density of water causes the separation of electromagnetic spectrum. Also visible to the human eye is the curvature of a rainbow. After a storm hits, there is only a certain amount of water droplets suspended in the atmosphere. As the sunlight hits these specific droplets, a curved rainbow can be observed with respect to the curvature of the Earth.
Not only does sunlight interact with rainwater, but it also interacts with acid rain.
As we know, rainbows can come in many different sizes, and all are unique to one another. The size in particular is determined by the makeup of water droplets, and scientists determine if there are chemicals in the atmosphere by simply observing it.
In particular, acid rain reacts differently with the sunlight as it passes through, resulting in a rainbow with a smaller radius. Acid rain results when sulfur dioxide and nitrogen oxide are present in the atmosphere and get absorbed in the precipitating rainwater. The acid then has a different refraction, and the interaction with water molecules together contributes to the change in rainwater and the angle with respect to sunlight that the rainbow is observed. The angle at which the rain interacts with the light can be used to estimate the pH value of the rainwater.
But what exactly are acids, and what is the composition of an acid? When other substances are added into water, there is a pH change that occurs. Acidic solution has more H+ and a lower pH, and alkaline solutions have more OH- and a higher pH. A pH of 7 means that the solution is neutral, while under 7 is acidic and over 7 is basic. So from the words acid rain, you might guess that it means rain that has a pH much lower than 7.
You would be right. That's exactly what it is.
But how does it form?
First, sulfur dioxide and nitric oxide are produced by the combustion of fossil fuels. When these gases rise up in the atmosphere, they can react in a few different ways to produce acid. 2 molecules of sulfur dioxide can react with diatomic oxygen gas in a combustion reaction to produce 2 molecules of sulfur trioxide. Then, each of those sulfur trioxide molecules reacts with liquid water from cloud droplets to produce H2SO4, also known as sulfuric acid. This is the acid that then affects the composition of the water droplets in rainbows.
Alternatively, two molecules of nitrogen monoxide can react with diatomic oxygen gas to produce two molecules of nitrogen dioxide. Then, these two molecules react with water to produce nitric acid and nitrous acid. H2SO4, HNO3, and HNO2 are the products remaining.
But how did these actually form to create acids within the rainbow?
So what essentially happens is these molecules are dissolved in the water, and obviously they decrease the pH value. That's as simple as we know it. However, if we break it down, what happens actually is these molecules donate one of their H+ ions, and by the Bronston-Lowry theorem, this makes them an acid. One example of this donation of one of the H+ ions to a water molecule would be H2SO4, which then becomes HSO4, which would result in a water molecule gaining a hydrogen ion and producing H3O+.
The more of these molecules that dissociate, the more H3O+ is created, which makes a stronger acid. Typically, the strongest of acids will dissociate completely, and each of those acid molecules will dissociate to form an H3O+ molecule.
Sometimes, in HNO2's case, these acids are weak, meaning they do not dissociate completely. This means that most of the molecules remain intact when they are put in water, so most of the HNO2 molecules remain HNO2 molecules. However, H2SO4 and HNO3 are strong and will dissociate completely, which gives them the highest effect when forming rainbows. Ultimately, the more acidic the rain is, the more H3O+ that dissociates, forming a larger rainbow with a greater radius, and it appears bigger to the human eye.
We were fascinated by the colors and how something so pretty could form from something so dark. Sometimes, periods of your life are dark and you need something bright and cheerful to lighten the mood. Rainbows represent just that, and in terms of chemistry, learning how the different colors come to light is interesting and useful.
Thank you for listening to this episode of Chemistry Connections.
For more student-ran podcasts and digital content, make sure that you visit www.hvspn.com.